Okay, let's dive right into this explainer. Today, we're tackling what is probably the ultimate mismatch: the finite human mind versus infinity. I mean, think about it. How did a biological creature, born on a rock with very clear borders, manage to invent a concept that literally has no physical boundary? It's honestly a wild story about the sheer limits of human cognition and what exactly happened when we just flat out refused to accept those limits.
To get into the right headspace for this, I want you to picture a single grain of sand. You can count it, right? 1. Now imagine a handful. 2, 3, maybe 1,000. Scale that all the way up to an entire beach. Now we're at 1,000,000. Just keep going until your brain is practically vibrating, barely able to process the sheer quantity of what you're imagining. And then I want you to ask yourself a super weird question. What is the biggest possible number?
You might instantly guess a billion, or a trillion, or, maybe you go big and say a Google, which is a 1 followed by 100 zeros. But math always has a trick up its sleeve. And it's a trick that completely shatters our everyday common sense intuition about how things work.
Because here is the kicker. Whatever massively unimaginable number you just thought of, I can always just add 1. Which means, simply put, there is no largest number. And the very second you realize that, you've essentially dropped your mind straight into a void with absolutely no end. You've just stepped into infinity. But wait, we can't touch infinity, right? We can't travel to it. We can't put it in a box. So how on earth do we actually wrap our heads around it?
Well, this brings us to our very first major misconception. Infinity is not just, a 1 with a billion zeros after it. It isn't simply an extremely large number. It represents something fundamentally different. It is an unending process, an absolute absence of a finite boundary. If you're counting 1, 2, 3, 4, there's literally always another number waiting. You never actually arrive at infinity.
And trust me, if this is hurting your brain, you are definitely in good company. The ancient Greeks really struggled with this. Back around the 5th century BCE, the philosopher Zeno came up with his famous paradox of Achilles and the tortoise. Imagine Achilles gives a tortoise a head start in a race. To catch the tortoise, Achilles first has to run to the exact spot where the tortoise started. But obviously, by the time he gets there, the tortoise has moved forward a little bit. So Achilles has to run to that new spot. But the tortoise has moved again, and again, and again. Zeno was pointing out what seemed like an impossible paradox. How can someone complete infinitely many, progressively smaller steps within a finite amount of time? In reality, of course, he catches the tortoise. But mathematically, this totally broke their brains.
This actually caused a massive philosophical divide. Aristotle looked at this and approached it super cautiously. He made a distinction between what he called potential infinity, which was like the act of counting forever, he was totally fine with that, and actual infinity. Aristotle was deeply uncomfortable with the human mind imagining a completed, actualized infinite collection existing out there in physical reality. He just couldn't stomach the idea of a box that literally held every number.
But while the Greeks were playing it safe, ancient Indian intellectual traditions were boldly expanding our psychological imagination. They were incredibly comfortable contemplating these enormous, unbounded quantities. Look at the 7th century CE. We've got mathematicians like Brahmagupta giving us systematic rules for zero and place value notation. Meanwhile, Jain mathematics was already out there classifying numbers into finite, innumerable, and infinite quantities. And Hindu cosmological traditions were exploring the kalpa, timescales so immensely huge they completely dwarf to human life. By developing sophisticated abstractions, especially zero, the human mind could suddenly manipulate concepts that were way, way beyond physical, countable objects like apples or cows.
So, looking at this timeline, we can essentially map the evolution of human cognition. We start with Zeno's ancient paradoxes in the 5th century BCE, move to Brahmagupta's zero in the 7th century, which paves the way for Isaac Newton's calculus in the 17th century, and finally lands at George Cantor's sets in the 19th century. We are literally watching the chronological leap of the human mind, moving from ancient physical puzzles to pure, modern abstraction.
And that brings us to the 17th century, the era of taming the infinite. This was a huge turning point. This is where the human mind basically says, okay, enough is enough, I'm taking control of this thing. Isaac Newton and Gottfried Wilhelm Leibniz independently developed calculus, and calculus did something practically magical. It finally gave humans a rigorous language for dealing with continuous change, limits, and infinitely small processes.
And this perfectly illustrates how taking control of infinity literally changed our actual physical world. Newton managed to turn the philosophical headache of infinitely small changes into incredibly practical tools. I mean, to model a planet that is continuously moving through space, you need calculus. Today, the bridges we drive on, modern machines, fluid dynamics, electronics, spacecraft, they all depend on mathematical ideas born from this revolution. Infinity went from being a mind-bending paradox to arguably our ultimate engineering tool.
But I gotta warn you, if you think we had it all figured out by then, the 19th century came along and completely shattered human intuition all over again. A German mathematician named George Cantor stepped onto the scene and proved something that honestly sounds absolutely impossible. He proved that there are actually different sizes of infinity.
Okay, to grasp just how weird this gets, let's walk through a famous thought experiment popularized by mathematician David Hilbert, known as Hilbert's Hotel. Imagine a hotel with infinitely many rooms, right? And every single room is occupied, completely full. Then a new guest walks into the lobby. A normal manager would say, "Sorry, we're booked solid." But this manager, they say, "No problem." They just move the guest in room 1 to room 2, the person in room 2 moves to room 3, and so on forever. And suddenly, room 1 is completely free. An entirely full, infinite hotel miraculously accommodated a brand new guest. Although, man, I would not want to be the housekeeping staff at that place. Finite quantities absolutely do not behave this way. And Cantor took this weirdness even further with a totally revolutionary discovery. Think of whole numbers. 1, 2, 3. There are infinitely many of them, right? We call this countably infinite. But now, think of all the decimals, like 0.1, 0.01, 0.001. Cantor proved mathematically that the set of these real decimal numbers is uncountably infinite. It is a fundamentally larger infinity than the whole numbers. Literally, some infinities are bigger than others. It was such a deeply counterintuitive discovery that it faced massive resistance at the time. But today, it's the absolute foundation of modern set theory. And honestly, the wildest part about all of this, the human brain was never designed to do this. Our cognition evolved to deal with finite, immediate threats. We evolved to find food, to avoid predators, to judge the distance of a rock we just threw. We certainly didn't evolve to understand uncountable sets, or infinite dimensional spaces, or quantum mechanics. Yet, somehow, this biological animal developed the symbolic systems to explore them anyway. It's really the ultimate triumph of the mind over its own biological limits.
But this success leads us to a profound philosophical mystery, treating infinity as the mind's ultimate mirror. We invented this incredibly complex, multi-layered concept. But does it actually exist out there in the real universe? Like, is physical space actually infinite? Are there infinitely many galaxies?
To answer that, we have to make a pretty stark distinction. Mathematical infinity is real, but in the sense that it's a rigorously useful tool of the mind. It's what powers artificial intelligence, it models complex computer graphics, it helps send satellites into orbit. But physical infinity? That remains a totally unproven, speculative state of the universe. Modern cosmology still cannot give us a definitive answer on whether the physical universe itself is spatially infinite. And the crazy thing is, we may never completely know, because the human mind is constantly discovering the limits to its own ability to reason. The philosopher Immanuel Kant argued that asking questions about the universe's ultimate limits just pushes our reasoning into inescapable contradictions. Later, mathematician Cantor and Gödel made things even stranger with his incompleteness theorems. He basically proved that within any sufficiently powerful formal system, there will always be true statements that literally cannot be proven using the system's own rules. Our minds are absolutely brilliant, but they do have fundamental boundaries.
So why do humans even need infinity? Well, because we possess two extraordinary abilities. We can abstract, and we can imagine beyond our own direct experience. A child looks at the world and sees 1 apple, 2 apples, 3 apples. But an adult mind abstracts that concept. We see n objects. And the exact moment you abstract it to n, you intuitively realize that n plus 1 is always possible. There is no final boundary to the rule. We didn't trip over infinity in a forest. It emerged from a rule inside our own heads.
Which brings us to a really beautiful, deeper message here. We are finite creatures. Our bodies occupy tiny little spaces, and our brains are made of just a few kilograms of matter. Yet inside those finite brains, we created a concept that has no beginning, no end, and no final boundary. We didn't have to build a spaceship and travel to the very edge of the cosmos to find infinity. It was born right inside us. As the explainer points out, infinity isn't merely a mathematical idea. It is a portrait of the human mind.
So I want to leave you with this final provocative thought. Think about human curiosity for a second. Think about our relentless, unyielding drive to always push past the edge of what we currently know. Did we really discover infinity hiding out there in the math, or did we invent it simply by being the one creature in the known universe stubborn enough to always ask, what comes after this?